We're kind of shifting gears a little bit right now. We're going to be talking about the sample proportion. And let's just kind of dive in and tell you what the sample proportion is. Okay. We have a case study here. Rob R. Barron, venture capitalist, has an idea for a product. Before investing much capital in the development of the product, however, he wishes to determine whether there is a market for it. What should he do? Well, the information he needs is what proportion of the population is interested in his product. In order to estimate this, we will review some old material. And we'll start by going back again to Bernoulli experiments. Recall that a Bernoulli experiment is one in which there are two outcomes. There's a success or failures. It's like a jar with red beads and blue beads. Two types of things can happen. There is a fixed probability P of success, and we have a random variable x that is defined on the outcomes of this experiment, has a value of 1 for successes and a value of 0 for failures. Now, here's the thing. This is exactly the same as a binomial experiment with one trial and a probability P of success. Okay, so recall we did the very, very painful calculations to show that if we had a binomial random variable with n trials and P successes, that the expected value there for that was n times P, and the standard deviation was the square root of n times P times 1 minus P. When we set n equal to 1 for a Bernoulli trial, this is what we get. Our expected value is the proportion, and the standard deviation is the square root of P times 1 minus P. Okay. So we will let success be a member of the population that is interested in product, and we will let x be the random variable that is 1 for success and 0 for failure. Its mean, okay, and we've just seen this, is P, the proportion of the population that is interested in the product. We will sample in order to get an estimate of the mean of P. Okay, so we let n be equal to sample size, and we'll let x be the number of successes in the sample. So here we have our variable. We sample this random variable. Now think about it. This is a random variable. It's either 1 or it's 0. It's 1 for success, it's 0 for failure. So what we're doing here is we're just adding up all of these 1s and 0s. Well, how many 1s do we have? Well, we have x successes, so we have x 1s. So we have 1 up here, x different times, the rest is 0. So the numerator is equal to x. And so this x bar is equal to x over n. Now, just as x bar is an estimator for mu, this x over n is going to be an estimator for P. Okay, now let's look at sigma. Okay, it's equal to the square root of P times 1 minus P. Well, it's going to be estimated. Okay, we estimate P by x over n. Okay, we put this in. Then we divide both sides by the square root of n, and I do some math. And when I do, I get my standard error of the mean is estimated by the square root of x over n times 1 minus x over n divided by n. Okay, that's a lot. I'll show you the easier way to do organize your calculations. And so we got this e times the z, our margin of error then is z equals z sub alpha times the standard error of the mean. Okay. Okay, so to get a 90% confidence interval, Rob takes a sample of size n equal to 100, and n has to be greater than or equal to 30. Okay, right, for this to work. This sample of Rob's has 33 successes. Okay, so he's got alpha is equal to 0.1. The alpha over 2 is 0.05. We do the table lookup. Z is equal to 1.645. N is equal to 100. X is equal to 33. So X over N is 0.33. 1 minus X over N is 0.67. And so we go and we make those substitutions into our formula for the standard error of the mean. And so it's just cleaner if we do it this way. And so I've got E is equal to 1.64 times this quantity. You do the math, and it's equal to 0.077. Now I'm going to be taking these out to 3 decimal places, you know, for my population, for my sample proportion. And so my P, okay, we know the 0.33 is probably wrong. It could be too little, so we would add the margin of error. It could be too big, and so we subtract it. And so we get a confidence interval, which is P is between 25% and 41%, with 90% confidence. Example 1. Okay. Bertram B. Bottlebutt has sampled 45 of the bats that reside in Grubbs Hall and has found that 27 of them are actually vampires in disguise. Determine a 95% confidence interval on the proportion of Grubbs Hall bats that are vampires. Okay, so 95% gives me alpha equal 0.05. Okay, divide that by 2. Do a table lookup on that. Okay, N is 45, X is 27. We carry out the division on that, and it's 0.600. I do 1 minus that, that's 0.400. I feed my formula for the standard error of the mean on all of these different numbers, and grind it out at 1.43. Okay, our estimate of 0.60 could be too low, so we add 0.143 to it. Could be too high, so we subtract it, and thereby get our confidence interval that P is somewhere between 45.7% and 74.3%. Okay, what would your reaction be to a headline that said almost 75% of the bats in Grubbs Hall are vampires, putting aside, of course, that vampires don't exist? Well, the thing is, that's only one end of the confidence interval. Okay, so you take this is a way people kind of fudge their case all the time. You take the upper end of the confidence interval, and which is 0.74, and you could say, well, that's almost 75%. But you're leaving out the fact on this the other end, it could be as few as 45.7%. So you have to have an interval. You also have to know what level of confidence is. So when you're reading a story and it only gives you one end of the confidence interval, you need to take that with a grain of salt. Okay. Margins of error for sample proportions tend to be relatively huge. Okay, many polls will give their results at plus or minus 3%. to get a 95% confidence interval, this would require you to have n equals to 1,000. So you need to have a large sample to have a small margin of error, okay, for a sample proportion problem. Okay, example 2. Egregious felon, local politician, had 1,000 local residents polled as to whether they would vote for him in the race for dog catcher. Of the 1,000 polled, 27 said that they would vote for him. Determine a 95% confidence interval of the population that will vote for felon. Okay, again, so we've got 95% confidence. That gives us alpha equal 0.05. It's a confidence interval, so we'll divide that by 2. We'll look that up. It's 1.960. Okay, a sample of size 1,000 with 27 successes. This gives us that x over n is equal to 0.027. We take 1 minus that, that'll give us 0.973. Okay, feed the formula for margin of error then. And this gives us that E is equal to 0.10. So get 0.27%. It's probably wrong. 0.027, probably wrong. If it's too low, we add 0.1 to it. If it's too large, we subtract, and so we get that P is between basically 1.7% and 3.7%. You could round it off to between 2% and 4%. He is not going to win.